Hello everyone. Recently, I've had the privilege for the past couple months to work on these little robots and mentoring these kids with these robots, and these are VEX IQ, and they're a lot much simpler than what I've worked on in the past. As you know, if you've seen in some of my previous videos, I've been in charge of the robotics team at my high school for 4 years, so I built much more complicated stuff such as this one right here, which was for pushback that took me 4 months to build. The process here of building one of these involves having 3D instructions on my laptop, and it comes in kind of like Lego boxes almost, where it's plastic containers and plastic bags, and each robot consists of 4 kits over here. So you can see we have 6 kits in total. So I built 6 robots. This was just for one school, so in total I've worked on about a dozen of these. Half of the Swish HeroBot model, which is like the tutorial model, and I had to build 12 more of them in total, or 11 more in total, which was a dozen about. And over here you can see my workspace. After we got some of the driving bases done, you could just test them around. So we had some of the kids drive them around a little obstacle course, which we made from lots of the little boxes and stuff, which was nice to see. And just improving driving, which was cool. So this is a completed model of the Swish HeroBot tutorial model for VEX IQ. And as you can see, we have a catapult mechanism on here, which is pretty awesome. So it winds up the catapult with a ratchet, and then it reverses and releases it like that to fire the ball. So I have some coded here to fire in sequence and do a little like move in sequence. So some examples, which is nice. And then I have them drive up one at a time towards me. And these are the 4 for the one school that I built. Now that you've seen them, that they can throw balls, you might be wondering what the objective of the game is. So here's an arena, well, part of the arena that I built, which is the actual nets. So the balls come through the top, they count as points, they roll down a ramp at the bottom, and then can be collected by students and placed back in the robot to fire again. These actual pieces took me about a week of constant work before I had them finally assembled, and then I divided them in half, which is 1 net per school. Now for a more hands-on look, I actually have one of these kits that I'm repairing currently. So you can see here I got the box and it's at my little workbench, and my goal is basically just to fix it because the catapult mechanism and some of the motors weren't working as intended. So I'll be working on that. In this box we got robot number 3, which doesn't work. We also have a ball from the field, and I gave it some spare parts that I'll use. The program for the kids, which is the preferred driving controls, so I called it VEX Code Controls, and I have it running the program section. So when I boot up a robot, it runs on the robot, and then the controller syncs to it, and the kids can control it from the little controller nice and easily with something they're familiar with and they practice with, because they're all the same code on every robot, which is nice. So robot 3 here is going to try to do a pickup sequence of the little ball, but the problem is some of the motors have some incorrect presets, so it's going to try to pick it up, but it's going to have lots of difficulty because the motors kind of cut out and get stuck. In order for you to actually pick up the ball and fire it, you need to have the catapult mechanism lowered all the way. On robot number 3 here, our catapult mechanically works with elastic bands, which is quite simple, but the problem occurs in the mechanism and the motors. So as you can see, the mechanism, which I have here, the ratchet, is built incorrectly with much shorter beams than it should have. So the ratcheting arm, when engaged, goes forward and begins winding up with an elastic band, pulling down on the elastic band catapult, and then after, when you reverse the direction, it does the opposite. It releases it, and the elastic bands pull out, firing the catapult and releasing all the energy from the elastic bands. Here's the controller presets I have coded for our robots, and then I also have some code for this stuff, which is quite simple. It's just 100% on everything, and then the motor group for the catapult is max torque. And then here it is set up on the robot, and I actually download it, which is cool. In conclusion, the past 2 months have been quite fun working on this project. And also, thanks so much for the support on my physics fair winning eddy current roller coaster project, which is pretty cool. And see you guys later.